All right, today we're going to talk about piecewise functions. A piecewise function is a function that's made up of two or more equations, two or more functions, two or more pieces. That's why we call them piecewise. Each piecewise function has specific x values that it uses for the different parts or different pieces. So in 4.2, we saw an example of a function looks like this, where we have this f of x equals 2x plus 3, and here's its graph. And you can plug any x value you want to into this graph. May not be shown on my graph, but you can do it. So I can find f of 7, I can find f of 13, I can find f of negative 42. Any x value you want will fit into this function. A piecewise, however, looks like this. So we still have one single f of x, but it equals one of these two pieces. And we could have more than two. We could have 3, we could have 4, however many pieces we want. But we're going to look at this, just these two pieces for now. So the two pieces have specific x values. So see how it says 2x plus 5? That's the function. But then it says I'm going to use that if x is less than negative 1. However, I'm going to use x squared if x is greater than or equal to negative 1. So there's certain restrictions on when to use the 2x plus 5 and when to use x squared. So I'm going to look over here at my graph. And we can see that there are these two pieces. So when x is less than negative 1, I'm going to look at my x values, all these less than negative 1, that means this graph is 2x plus 5. It would continue forever in this downward direction, but it stops right here at x being negative 1. And notice there's an open circle because it says it's less than negative 1. So that is an open circle. My second piece, x squared, is this graph, because it's when x is greater than or equal to negative 1, so greater than or equal to all of this side here on the right. So all of this is my graph. Notice that that's a closed circle because x is greater than or equal to negative 1. So closed circle there on that graph. It would continue forever in this upward direction though. Notice here with these two dots, this open circle means there's not actually a point right there. It gets really, really, really close, but doesn't actually touch that spot. So this is still a function because that point is there and that point's not exactly there. It's just really, really, really close. So this still passes the vertical line test to be a function. Okay. When we use our piecewise functions, besides being able to graph them and look at that, we can also still find our f of x values like we did in 4.2. So when we use our when we use our piecewise functions and we want to find an f of x value, let's say we want to find f of negative 7. The first thing you have to do is determine which piece of our function do you use. So our x value, and you're going to make this little change right here, there should be a negative. Our x value, which is negative 7, because we're finding f of negative 7, fits into one of these two parts right here. Negative 7 is either less than negative 1 or negative 7 is greater than or equal to negative 1. So we need to figure out which part it fits into. So is negative 7 less than negative 1 or is negative 7 greater than or equal to negative 1? Well, negative 7 is less than negative 1. So because it fits into that part, I'm going to use that piece of my piecewise, which was the top one. Because x is less than negative 1, I'm going to use this top part of my function. So to find f of, we need to make that a negative 7 right there. A couple of changes here on your notes. If you would make these for me, well, for you really. Make that a negative 7, which means in my x, I'm going to plug in a negative 7, so make that a negative. So I have 2 times negative 7 plus 5. And you would type that in your calculator or do it on your own, and you're going to fix that for me. 2 times negative 7 plus 5 should equal negative 9. So f of negative 7 is negative 9. You have to use this first piece because x was less than negative 1. So now if we want to find f of 5, so same thing, we need to figure out which piece it fits into. Is 5 less than negative 1 or is 5 greater than or equal to negative 1? In this case, 5 is greater than or equal to negative 1, so I'm going to use this second piece, which just says I'm going to take x squared. So to find f of 5, I'm going to do 5 squared, which would give me 25. So f of 5 is 25. Don't plug this 5 into this top part of your function, because this function stops when we get to x being less than negative 1. So this last question here asks you, well, what if we want to find exactly f of negative 1? Which piece does that fit into? So which piece does negative 1 fit into? Is negative 1 less than negative 1? Or is negative 1 greater than or equal to negative 1? Which one of these two pieces does it fit into? It fits into this bottom piece, since this is greater than or equal to. So if I want to find f of negative 1, I'm going to use this bottom piece again, which says I'm going to take f of negative 1, which is negative 1 squared. Remember to make sure to put this in parentheses before you square it. And then either on your own or in a calculator, you're going to type that in, making sure it's in parentheses, negative 1 squared, which means, remember, take it by itself. So negative 1 times negative 1. Two negatives give me a positive 1. So f of negative 1 is positive 1. Once again, you cannot put it in this top one because it doesn't fit into this restriction here. Okay, so when you go to find your f of x values, you have to identify which one it fits into, which one of the 2 or 3, depending on how many options it gives you. Then just do it like you did in 4-2. Plug it into x everywhere you see an x and simplify either on your own or in your calculator.